Hey everybody, welcome back. Chapter 6 is coming your way. I hope you're excited like I am. We're going to be solving inequalities. Inequalities. What does inequality mean? Not equal. I hope you said not equal, because that's exactly what it is. We're going to be solving inequalities using addition or subtraction. And it says solve and graph. Oh no, bummer. We have to graph what? Yes, you get to graph. It's exciting. It's an exciting time in math right now. We're going to be graphing inequalities using addition or subtraction. All right, so the very first thing I want you to write down is I want you to write down this entire slide, including everything in the middle. Write it all down, please. Thank you. All right, so when you look at an inequality is a statement that two quantities are not equal. Well, when we look at two quantities, okay, it's going to be something on the left side, something on the right side. Okay, they're not equal. So there are no equal signs here. Okay, the following signs are less than, greater than, less than or equal to, greater than or equal to, or just straight up not equal. Okay, we're going to focus primarily on these four. We might get into not equal a little bit, but primarily on those four. When you look at a solution of an inequality, when you think of solution, think answer. Okay, so when you look at a solution of an inequality, it is any value that makes an inequality true. So if I said the inequality of x is greater than 5, a solution of that inequality would be 6. It would be 7. It could be 8. Heck, it could be 143,925. Doesn't matter. Anything bigger than 5. Would 5, if I plugged in x equals 5, would that be an inequality? Or would that be a solution of that inequality? No, because 5 is not greater than 5. It's equal to. It's not greater. It's equal to. Yeehaw. Okay, moving on. You do not have to know, or you do not have to write this down. We're going to write down another slide. I do want to talk about this, though, because this is very, very, very important when we start graphing things. It says, if you look at these, notice if you look at this graph, we know that x is less than 5. If I typed in x is less than 5, well, we know anything less than 5 is going to be a solution of that inequality. We graph that on a number line by shading everything to the left of 5. That means 4, 3, 2, negative 47 is all included. Just make sure you have an arrow pointing to the left. Now, when you look at this, though, it has an open circle, has an open dot, as I like to call it. That open dot means that every number up to 5 is going to be included in that inequality. 5 is not included with an open dot. That means 4.9999999999999999999 is included, and then an infinite number of 9s behind that. Okay, but 5.0 is not included with that open dot. Same thing here on the second one. Okay, we have x is greater than a negative 1. We have shaded, it's shaded to the right here, because whenever we go to the right, we get bigger, we're getting greater, and again we have our open dot because negative 1.0 is not a solution. It's impossible. Okay? Again, all real numbers less than or equal to half. Notice, again, we're looking at less than, so we're looking at all numbers to the left. Think less is left. Okay, all numbers to the left of half on a number line. Okay, so everything less than, that includes 0 and all of your negative numbers. It's going left. But this time, notice it says less than or equal to. So in x is less than or equal to half. Is half a solution? Yes. And because of that, we plug in a closed dot. A closed dot. Okay, because half is a solution. An ugly arrow. Okay, same thing with the last one where x is greater than or equal to 0. We have a closed dot again. Okay, and we have shaded to the right. All right. All right, that's a lot of information that you didn't have to write down, that you had to listen to. So we need to get your hand working a little bit, which means let's write a note. Here it is. And this kind of explains everything that I just talked about. It says, if the endpoint isn't a solution, when it is not a solution, that's going to be your greater or less than symbols. So in a greater or less than symbol, use an open dot. Okay? Greater or less than symbols, use an open dot when graphing. When graphing. So think, greater or less than is an open dot. If the endpoint is a solution, and it is a solution whenever we have greater than or less than, greater than or equal to, or less than or equal to, that is going to be our closed dot. Okay, so if I give you x is greater than, let's say, 4, on a graph, is that going to be open or closed? It's going to be an open dot. So on my graphed equation, I want to put in 4, and a lot of times I just put in 3 points, 3 and 5. Okay, it is going to be an open dot, as we just talked about, because we have a greater than symbol. Now, if I look at, I just plot my open dot at x is at 4, that tells me that all the equation, or this is everything leading up to 4 is true, but 4 itself is not. Now, which way do I shade, though? Would I shade to the right, or would I shade to the left? Well, we're talking about greater than, I would shade to the right. Okay? So, or you can do a little arrow that way to make it nice and easy. Okay, now we're going to get into a couple of graphed problems. All right? So let's go over a couple of graph problems. All right, so it says graph each inequality, and what I want you to do is I want you to write this down, and I will graph this first one with you, and then I want you to do the other 3 by yourself. Okay, so pause now, write all this down, and I will begin in just a second. All right, so now we have x is less than 2. That number right there, that is important. X is less than 2. So if I look at x is less than 2, very first thing is I draw a number line. Okay, and what I want on a number line is at least 3 points. At least 3 points. So what I like to do is I like to put the numbers to the left and to the right of my 2 here, of my answer there. Okay, so very first thing I do is I think to myself, okay, my equation is less than. Is that an open or closed dot? So look at your notes and see, would that be an open or closed dot if it is less than? It's an open dot. Yep. Good. We have an open dot because that means 2 is not a solution. Now it says graph it. We need to graph something less than 2. So if I go less than 2, am I going to go the side of 1 or the side of 3? Well, is 1 less than 2? Absolutely. Because I just checked, if 1 is less than 2, and that's correct, which is true, I know that 1 is included in my solution set. Okay, so because of that, I need to shade to the left. Okay, you don't need to put this point on. All I'm looking for is this right here. Okay, this would be your answer. An open dot shaded to the left. Okay, because that tells me everything less than that 2 is a solution. All right, next one. If x is greater than or equal to negative 0.5, then you have x is greater than 2.5, and then m is less than or equal to negative 3. So give this one a shot, all 3 of these, and see if you can come up with the answer. All right, so if you look at this, x is greater than or equal to a negative 0.5. Very first thing is I'm going to draw my number line. I'm going to put negative 0.5 here. So I'm just going to flip it to a fraction. Makes it maybe a little bit easier. And I know to the left of negative half is negative 1, and just to the right is 0. Okay, if I look at this, very first thing I do is I look at that symbol or that inequality sign. It says greater or equal to. Well, when it says or equal to, can negative half be a solution? Yes, it can. Because of that, it is a closed dot. So I have a closed dot. Now it says greater than. So which one would be greater than a negative 0.5? Is it negative 1 or is it 0? 0 is greater than negative 0.5, so I shade to the right. Answer, done. Okay, x is greater than 2.5. Very first thing is draw my number line. Put 2.5 in the middle. I'm going to put 2 on the left side, 3 on the right. It is very, very, very important that you graph that correctly. Less numbers to the left, larger numbers to the right. If you don't, that's going to set you up to get it incorrect. Okay? Then, once I have my number line set, I look at my symbol. It is greater than. Because it is greater than, it means it is not included in my solution set. I have an open dot and number greater than 2.5. What's bigger than 2.5? 2 or 3? 3! I know I need to shade to the right because 3 is a solution. Last one on this slide. Okay, here we go. Again, negative 3. What's to the left of negative 3? Negative 4. And to the right, negative 2. If you want to do 2 other points, that is perfectly fine. I just want you to be able to understand it. So it says m is less than or equal to a negative 3. So negative 3, is that a solution? You betcha. Point. And am I going to be shading to the left or to the right? Well, which one's less? Negative 4, negative 2. Negative 4 is less than negative 3, so I shade to the left, to the left, da-da-da, to the left. Oh man, I'm horrible at singing. Okay, I'm so glad you are listening to this on headphones because Mr. Sheeman singing just is not good. All right, so those would be the graphed inequalities of each one. Excelente. All right, so what I want you to do here, it says you can add the same numbers. These are properties of inequality, both the addition and subtraction. So try this out now. Okay, it says you can add the same number to both sides of an inequality and the statement is still be true. Same thing with you can subtract the same numbers from both inequalities and the statement is still true. This is true for all symbols, greater, less than, or greater than or equal to, and less than equal to, or equal to, okay? This means, just like if I gave you x plus 4 is equal to 7, very first thing is I would subtract 4 on both sides, and I would have x is equal to 3. That's the same exact thing is true on inequalities. If I gave you x plus 4 is greater than 7, well, I would subtract 4 on both sides, and I would just have x is greater than 3. They're the exact same thing. You got to think of that inequality sign just like an equal sign. Treat it the exact same way. If you do that, you will do it correctly. Okay? Okay. So write this down, and then what I want you to do is I want you to solve it just like you would a regular equation. X plus 12 is less than 20, and d minus 5 is greater than or equal to negative 7, just like you would if they were equal signs, and then graph the solution. See what you come up with. See if you can get this. Okay? Pause now. All right. So the very first thing I want to do on this x plus 12 is less than 20. I need to solve the equation. If I solve it, okay, then I can graph it. Okay, it says x plus 12 is less than 20. Okay, very first thing, I solve it just like I would a regular equation. I subtract 12 from both sides, and I now have x. I keep that symbol of less than, and I subtract, which is 20 minus 12 is 8. That tells me every number less than 8 would be true in this overall equation? So give me a number less than 8. 7. So if I look at, and I went back into my original equation, is 7 plus 12 less than 20? You betcha. 19 is less than 20. Okay, so I just went back and I just checked my answer there. So now what I have to do is graph my solution. Okay, my solution, not the overall equation. I graph the solution. So when I graph that, I'm graphing this x is less than 8. Okay, so I plug in my point of 8, plug in one number to the left, one number to the right, and question is this an open dot or a closed dot? And it is an open dot. Why is it open? Because 8 is not a solution here, so we have an open dot at 8. We already plugged in 7 to see if that was true, and it was. 7 works in the equation, so shading to the left or to the right? To the left, shading to the left. Awesome. Okay, next one, very first thing is solve the inequality. Okay, when you solve this inequality, we need to add 5 to both sides. So we have D, keep that symbol in there. D is greater than or equal to, negative 7 plus 5 is a negative 2. Dos negativo, negativo dos. Look at that. We're speaking Spanish and math? Oh my goodness. Okay, so now we have a negative 2. Plug it in on my graph. Put 1 to the left, 1 point to the right. And you find a number which is greater than or equal to a negative 2. First of all, open dot or closed dot? Open, closed. Which one? Which one? It is a closed dot. Closed dot. Why? Because negative 2 is a solution in that equation. Negative 2 is greater than or equal to negative 2. That is true. Hey, I just rhymed. I do it all the time. Okay, so now when I look at this, I'm looking for a number greater than or equal to a negative 2. And that is negative 1 greater than or equal to negative 2? Yes, it is. So because of that, a shade to the right. Okay, one common mistake is to plug this negative 7 in instead of negative 2, and we don't want to do that. Okay, you don't want to do that. You want to plug in, you want to solve, okay, for the inequality, or solve for the answer that you get. This is my answer. D is greater than or equal to negative 2. So that answer, we graph my answer, not the problem. Okay, awesome. Next, this is the final slide of the day. Final slide. It says, a racer finished a 5-kilometer walking race in 45 minutes. Let R represent any faster kilometer per minute. Write an inequality that describes R. So we're going to use R as our variable. I want you to see if you can come up with an inequality, and I want you to solve that inequality. You don't have to graph. It just says write an inequality, but I also want you to solve that inequality. So pause now, see if you can come up with it. Fantastic. Good luck. All right, so when you look at this, a racer finished a 5-kilometer walking race in 45 minutes. Let R represent any faster kilometers per minute. So the very first thing is you will notice we have kilometers per minute. So if you set that up using the labels, it would be kilometers per minute. Correct? Correct. So a racer finished 5 kilometers walking race in 45 minutes. 5 kilometers in 45 minutes. In other words, 5 kilometers in 45 minutes, that means the racer did 1 kilometer every 9 minutes. Okay, so, but now we've kind of found the rate at which that racer finished, 1 kilometer per 9 minutes. What we want to figure out is an inequality. Not someone who's moving at that pace, but someone who's moving faster. So my racer is going to be moving faster than 1 kilometer per minute, per 9 minutes. Okay, so if I look at that, would my racer be moving at a faster pace? Would he be moving at a time greater than or a time less than this equation? Well, he would be moving faster, so we want to get more kilometers per 9 minutes. So we want to have a greater speed. We want a faster speed. He's going to be walking at a faster speed than 1 kilometer every 9 minutes. He wants to be 2 kilometers every 9 minutes. He wants to be cruising. He wants to be like Turbo. Turbo. You ever see that movie? Me either. I'm not sure if it would have been good. Let me know if it's good if you've seen it. All right. So that's all I have for you today. That's the last note of the day. Okay. And again, all you had to do is write an inequality, and that was R is greater than 1 kilometer over 9 minutes. If you did divide that out, it would be 0.1 repeating. If you did that, just 0.11 would also work. Okay, what I want you to do is I want you to go to the next slide and do your homework. Here's the next slide. Okay, if you look at page 326 and 328, you're doing 4 through 60 evens. Number 56, if you look at 56, it has 2 steps. There's 2 problems. There's an A, there's a B. I want you to do both A and B. I want you to do A and B. You're getting a lot of Spanish today. Man, you guys are lucky. Okay, and then what I want you to do is I want you to do 76 through 82, and I want you to do the evens there. That one is going to be slope-intercept form, just like we just did in the last chapter. I know you loved it so much, so I threw them in there. All right, have a wonderful day. See you later. Get working on your homework.